Alright, these problems are a little different. I've given a graph right here. It's not the highest resolution in the world, but you can probably get the idea of what it looks like. First thing it says, for each graph, describe the end behavior. The end behaviors are right here. Alright, this is one end, this is another end. Same thing with here. This is one end where the arrows are, and this is the other end. Let's take a look at this one first. What we're going to do, now you're going to talk about x approaching things. You're going to talk about x approaching negative infinity. What happens to this graph right here? As x goes to the left, goes towards the negative, what happens to this? Well, it goes down, doesn't it? As x goes to the right, or as x approaches what we call positive infinity, what happens to this graph? Well, that goes down as well. So this is how we write it. We say, now I actually write it a little differently than they do in the book. I kind of like my way a little better. So let's do this. We say as x, let me fix something. Alright, let's try this again. Get my pen working. As x approaches negative infinity, so as x approaches negative infinity, which means to the left. As we go to the left, what happens to our function? Then our function, which is f of x, where does it go? It goes down. Well, where is down on the y-axis? That's negative infinity as well. So f of x approaches negative infinity. Now watch. We just talked about as x goes to the left. Now what happens as x approaches positive infinity? If it keeps on going to the right, what happens here? This goes to negative infinity. So as x approaches positive infinity, my infinities aren't that great, f of x approaches what? Well, they go in the same direction. So it doesn't matter. If x goes to the left, the y or the f of x goes down, negative infinity. As x goes to the right, then your function, your f of x, goes down as well. They both go in the same direction. All right, your functions. It says determine whether it represents odd or even. Now, if you remember, just to jog your memory a little bit, if you had a parabola, what was that? That was y equals x squared. What kind of a function was that? Well, look at the exponent. It was squared. If the arrows go in the same direction, then it's going to be an even degree function. Alright, so if you look at this, that was going in the same direction, so 2 is even numbers, so it's going to be an even degree function. Same thing here. As they're going in the same direction, it's going to be even. So this is part A. Part B would just be an even function. That's all you would say there. And now part C says state the number of real zeros. When we talk about real zeros, we're talking about where it hits on the x-axis. So this graph hits right here. That's 1, that's 2. Talking the x-axis, not talking y-axis, talking x-axis. 1, 2, 3, 4. So it's got 4 zeros. And you can just write it like this, just to make sure that we know what we're talking about. Let's come over here and do the same thing. I set it up the same way every time. Watch. I say as x approaches negative infinity, then what does your function do? Watch. As x approaches this way, what happens to your function? It keeps going up, 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 up. How far up? Well, f of x approaches positive infinity in this situation. So as x goes to the left, my function goes up. And then as x goes to the right, to positive infinity, then let's take a look at this graph and see what the function does. So as x goes to the right, what happens to my function? Well, it starts going down, right? The further I keep going to the right, the further down it goes. So f of x approaches what? This is your function. Approaches down, which is negative infinity. That's part A. Part B, determine whether it's odd or even. They're going in different directions. Look, this is going up, this is going down. If they're different directions, that's odd. So we say it's an odd function. Now part C says state the number of real zeros. Again, look on the x-axis. So there's 1, there's 2, there's 3. Notice the number of zeros corresponds with whether it's odd or even. So 4 zeros, even. 3 zeros, odd. And so we just write down 3 zeros. Looks difficult when you see all these crazy graphs, but when you understand what all that stuff means, it's not that hard. You just have to study it, that's all. Alright, let's move on. Alright, we're going to do some factoring here. If you look at this factor, it doesn't look like your regular trinomial factoring, but really about the only, and it doesn't have a greatest common factor, so what we're going to think about doing is grouping these together. If you group this together, just take a look at this parentheses. Now there is a greatest common factor just with these two, isn't there? 2 and 6, there's a 2. What about the a? There's an a in common. Anything else? Nope. Factor it out, see what we got left. That's a k. It's supposed to be a k, it's kind of ugly. Minus, factor out a 2 from the 6, that's a 3. Already factored out the a, so there you go. And we're just going to put plus and then k minus 3 right here. Now if you look at this, check it out. They kind of rigged this, didn't they? So look, you've got a greatest common factor with these two as well. Remember, look at this whole thing right here and this part here. So there's a common factor of k minus 3 inside of here. That extra parentheses looks a little ugly, so I'll just factor out a k minus 3. What are you left with? If I take out a k minus 3 from this, I'm left with a 2a. Put the plus sign. If I factor out, or divide out is really what we're doing, dividing out a k minus 3, what are we left with? K minus 3 divided by k minus 3 is just a 1. And there it is. This one's a little different. You got to remember something that we had learned before. This is called the difference of two cubes. Let me write this down very quickly. Alright, this one's called a difference of two cubes, and this is what it looks like when you factor it out. We used a and b, I think, when we first taught it, so I'm using it again. You just have to memorize this. Remember, this is the same opposite positive one, so it's the same sign as what we started with, then the opposite, then the positive. You just have to remember the order which these go in. That's just a matter of studying. So what we're going to have to do is we're going to have to rewrite this, though, because what this was a cubed minus b cubed is equal to this right here. We need to write this so it looks like something cubed minus something cubed. Kind of does, but not quite. So what we're going to do is we're going to write it, 27 is 3 cubed. So we're going to write it as 3x cubed, and 2 cubed is 8. So we're going to go 2, and then look at the y to the 6. What's being cubed there? Well, y squared is being cubed. So look, this is the a. Let's make that a different color. This is the a, and this is the b. So you're just basically going to throw that stuff into this little formula right here. Wherever you see an a, you're going to put a 3x. Wherever you see a b, you're going to put a 2y squared. So let's do this quickly. It's a minus b, so it's just 3x minus 2y squared. Parentheses. And let's spread it out. It's a squared, so we're going to take this a and square it. That's 9x squared. For some reason, I always like to do the last one before I do the middle one. 2y squared. And what I have to do, I have to square that. So that's going to be 4y to the 4th. And we're going to put a plus right here, plus right here, and we're just going to take these two things, this a and the b, and then multiply them together. So that's going to give you 6. 3 times 2 is 6, and then an x and a y squared, which is just xy squared. That's all there is to it. That looks like it's confusing at first. When you first learn this, if you know that formula and you know how to split this into this thing right here, it's just plugging and chugging into a little formula. Alright, write that down, make sure you practice it a few times, and you'll be able to get that pretty easy. Alright, 2 more to go. Alright, this is another little different type of problem. We're going to solve for x, but we're going to do some factoring with this. You're used to seeing x squared minus something x, alright, but we don't have it. We have x to the 4th. So what we're going to do, we're going to say let's use a different letter. Let's say let a equal x squared. I'll show you why. So instead of this being x squared, we're just going to make it an a. So if a is x squared, this is x to the 4th, so it's x squared squared, so it's going to be a squared. I don't know if that made any sense, but if you write it down, maybe you'll see it. So it's going to be 50a plus 49 equals 0. We're doing substitution is basically what this is called. We're just substituting in something a little simpler to this, because we can't factor this straight up the way it is. But if you take a look at this, now you can factor it. And we're not going to finish, we're not just solving for a, we're still trying to solve for x, so we still need to get x by itself. But let's go ahead and work this out. This actually factors real nice. So we've got an a right here and an a right here. So let's see, what do you think about 49? Negative 49 and negative 1, will that work? Negative 49, negative 1, yep, that multiplies to be positive 49, and it adds up to be negative 50. So remember what we're trying to do, we're trying to solve. So I'm going to go a minus 49 equals 0, and a minus 1 equals 0. A is 49, and a is 1. We're not finished though, because we're not trying to solve for a, we're trying to solve for x. Remember what we let. We let a equal x squared. So instead of a, we're going to say x squared is 49. So x is, take the square root plus or minus, it's plus or minus 7. Same thing here. Instead of a, it's going to be x squared equals 1, and x equals plus or minus square root of 1 is 1. We actually get 4 answers for this. Notice the 4 right there. We get 4 answers. Alright, only one more problem left, and we have to go to the next video for this one.